Let's be honest. Running medgamma on a typical hospital workstation, it's almost impossible. This is the unoptimized baseline model. We feed it subject 19,079,797, and look what happens. GPU memory spikes past 9 gigabytes. Welcome to an AI tools for medgamma CXR analysis. On the left, you can browse 233 sample cases or upload your own image by clicking the upload button or dragging and dropping. The right panel shows ground truth and generated reports. To get an AI analysis, type a question in the chat. For example, describe the key findings in this chest X-ray and press send. The model will analyze the current image and return a report in about 3 or 4 seconds. You can use it directly at our app or through the Hugging Face space. So how did we get here? Our workflow follows 5 major steps. First, model analysis. We evaluated medgamma's architecture from an edge deployment perspective, looking at memory footprint, quantization feasibility, and inference behavior. Second, dataset analysis. We selected Mimic CXR because it provides image inputs with ground truth reports, and we analyzed its report length and view distribution to understand text complexity. Third, cleaning and alignment. We standardized the report format, removing structural prefixes like finding and impression to ensure fair evaluation and stable training. Fourth, baseline reproduction and evaluation. We reproduced the original setup and evaluated performance using RadGraph F1, establishing a stable reference score. Finally, compression and distillation. We applied AWQ quantization and W4A4, W4A8 strategies, followed by knowledge distillation to recover reasoning quality. This pipeline allows us to reduce memory dramatically while preserving clinical logic. Behind the scenes, things get interesting. Medgamma's internal dimensions are non-standard, which makes naive 4-bit quantization unstable. We encountered repetition hallucinations, the model acting like a broken record. To solve this, we designed a precision label alignment distillation strategy. Instead of forcing raw compression, we guided the student model to preserve structural and clinical semantics. The result? A WQ quantization remains nearly lossless. Distilled models stay stable, and repetition is eliminated. In the end, the most terrifying side effect of extreme low-bit quantization isn't precision loss, it's model dementia. The model collapses into a repetition loop, inflating output length to 200+ words. Through alignment correction and knowledge distillation, we pulled output length back to an ideal approximately 35-word range and eliminated catastrophic outliers entirely. Our model doesn't just run at the edge, it runs reliably.